Today we are going to discuss about the topic carbon and its compounds. We know carbon can form more than 3 million compounds. Why it is possible by carbon? The reason we all know, that is the versatile nature of carbon. The versatile nature of carbon which enables the carbon to form more than 3 million compounds. Let's see the versatile nature of carbon. The versatile nature of carbon. The first reason of the versatility of carbon is catenation. Catenation. We know what is catenation? It is a self-linking property of carbon to form long chain. The definition is like self-linking property. The self-linking property of carbon. What do you mean by self-linking property? That means one carbon can form selfly linked with the other carbon to form long, huge molecules of carbon. That property is termed as catenation. The self-linking property of carbon to form long chain can be called it as catenation. And second reason for the versatility of carbon, we can call it as tetravalency. We know the valency of carbon atom is 4. Due to the valency 4, carbon can form 4 bonds with the monovalent atoms such as hydrogen. So, due to the valency of carbon 4, the tetravalency, carbon atom enables to form more number of compounds than other atoms. This can form 4 bonds with the monovalent atoms. Then the third reason for the versatility, we can call it as small size and medium electronegativity. We know carbon having small size and medium electronegativity. This enhances the carbon to form covalent compound. So this term can be correctly written as like this: carbon form covalent bonds, or carbon prefer covalent compound formation. Carbon prefer covalent compound formation. So the covalent bond formation of carbon is due to its small size and the medium electronegativity, which is around, the electronegativity of carbon atom is around 2.54. So, due to the third reason, we can simply say carbon forms covalent bond. What is covalent bond? We will discuss in this chapter in details. And fourth reason for the versatile nature of carbon, which is also related to covalent bond. Carbon can form single bonds, carbon can form double bond, carbon can form triple bond. That can be simply, we can call it as multiple bond formation. Carbon can form multiple bond. Carbon can form single bond, carbon can form double bond, carbon can form triple bond. This is the reason for the versatile nature of carbon. We are going to conclude it. We are going to conclude catenation, tetravalency and covalent bond formation of carbon and the multiple bond formation. Again, we are going to consolidate the definition of catenation. That means carbon can form long chains by the self-linking with the carbon. That property is known as catenation. Then carbon valency is 4, so carbon can form 4 bonds with other monovalent atoms. Then due to the small size and medium electronegativity, carbon follows covalent bond formation. So, and moreover, carbon shows multiple bond. Carbon can form multiple covalent bond, single bonds, double bond and triple bonds. Okay. Now we are going to discuss about bonds in carbon. I already informed you that carbon forms covalent bond due to small size and the medium electronegativity. So let us discuss what is covalent bond. We know a covalent bond is formed by the mutual sharing of electrons. We know carbon having atom number 6, electronic configuration 2,4. Either by losing 4, carbon can form stable K-shell electronic configuration if it undergo ionic compound formation, or gain 4 electron, again carbon form a stable electronic configuration. But we all know carbon can't form C plus 4 and C minus 4. That is the reason why carbon prefer covalent bond. So, what is covalent bond? Is covalent bond Cp formed by the mutual sharing of electron. Mutual sharing of electron. A covalent bond is formed by the mutual sharing of electron. Before we are going to take into consideration of carbon, let us consider how its two molecules form. We know hydrogen is having 1 electron in the valence shell, other hydrogen is having 1 electron in the valence shell. Then we know K shell consists of 2, that will give stability for hydrogen. So these two hydrogens are having same size, same electronegativity, so they will share their electrons mutually like this. On this own view, these two electrons are the part of this hydrogen. On this own view, these two electrons are the part of this hydrogen, and they mutually share the 2 electrons of each hydrogen atoms. One hydrogen having 1 electron, other hydrogen is having another 1 electron. They are mutually shared 1 pair of electron. They are mutually shared 1 pair of electron. In hydrogen molecule, they are mutually shared 1 pair of electron. So hydrogen molecule shows hydrogen single covalent bond. Single covalent bond. Because in the hydrogen molecule, 1 pair of electrons are mutually shared. Let us consider another molecule formation, oxygen. We know oxygen is having atom number 8, electronic configuration 2, 6. That means 6 electrons in the valence shell. Let us consider the first oxygen. This is another oxygen. Total 6 electrons are present around this oxygen atom. 6. And again 6 electrons are present in this oxygen atom. So we all know both oxygen demands 2 more electrons to complete their object or obtaining the stable electronic configuration. So one of the hydrogen should share his 2 electrons with these oxygens, and this way they will form a sharing bond. You can see on the part of this oxygen 1, 2, 3, 4, 5, 6, 7, 8 is octet is just completed, and the same manner 1, 2, 3, 4, 5, 6, 7, 8 this oxygen octet is also completed. So they are sharing their electrons. How many electrons they are sharing? 2 pair of electrons are shared between 2 oxygen atoms. 2 pair of electrons are shared between two oxygen atoms, mutually shared. So when the two pair of electrons are mutually shared between the atoms, we can call it as double covalent bond or double bond. Here in oxygen molecule, two pair of electrons are mutually shared. Here, so oxygen form double covalent bond. Let us consider another example. In the case of nitrogen, we all know nitrogen form, nitrogen molecule. Nitrogen is having atom number 7, so electronic configuration 2, 5. 3 more electrons want to complete the octet of a single nitrogen atom. So let us draw the electron dot structure. Electron dot structure of nitrogen. 1, 2, 3, 4, 5. Valence electrons of nitrogen is 5. Another nitrogen 1, 2, 3, 4, 5. So when two nitrogens comes together to form nitrogen molecule, they will share 3 pair of electrons between them. 3 pair of electrons, total 6 electrons are they togetherly shared. You can see here 1, 2, 3, 4, 5, 6, 7, 8. On the part of this hydrogen, his object is completed. And the same manner 1, 2, 3, 4, 5, 6, 7, 8. And on the view side of this nitrogen, his object is also completed. They mutually share 3 pair of electrons. They mutually share 3 pair of electrons between them. And such a way, nitrogen form a triple covalent bond between two atoms. Now we are going to consolidate in simple. We know a covalent bond is formed by the mutual sharing of electrons. A covalent bond is formed by the mutual sharing of electrons. There are 3 types of covalent bonds are there: single covalent bond, double covalent bond and triple covalent bond. In the case of single covalent bond, 1 pair of electrons are mutually shared. In the case of double covalent bond or double bond, 2 pair of electrons, that is total 4 electrons are mutually shared. In the case of triple covalent bond or triple bond, total 3 pair of electrons, total 6 electrons are getting shared, and such a way 3 type of covalent bonds are formed. We know at the beginning carbon can form all these 3 kinds of covalent bonds with the other carbon atoms. Okay. Now we are going to consider the covalent bonds, single, double and triple bond formed by carbon. See, we are considering first of all the molecule ethane, ETHANE. In ethane, 2 carbon atoms are present. We know around a central carbon atom there should be 4 bonds should be there, because carbon is tetravalent. We can satisfy the valencies of these carbons by bonded with hydrogen. You know, in this graphical representation of ethane molecule, in between 2 carbon atoms, they are shared 1 pair of electrons between 2 carbon atoms. 1 pair of electrons are shared in between 2 carbon atoms in ethane molecule. So 1 pair of electrons are shared in between 2 carbon atoms and they will form ethane molecule, and its structure is like this, graphical formula like this. 2 pair of electrons are shared between one pair of electrons are shared in between 2 carbon atoms, 1 pair, total 2 electrons, and they make a single bond between 2 carbon atoms. So carbon can form single bond with the other carbon atom. Here the single covalent bond is formed between 2 carbon atoms. We know here two electrons are joined like this. One pair of electrons are joined like this. Then another case, another example we are going to consider is ethene. You know, around a carbon atom, there is two carbon atoms are present. Around a carbon atom there are four electrons are present. I kept two electrons of this carbon atom on this direction, and these two electrons of this carbon atom kept this direction. Other two hydrogen atoms or two electrons are like this. It's better to do like this. A single carbon, two electrons like here, one is here, one is here. Other carbon atom, two electrons are kept here, other one is here, other one is here. Then one hydrogen atom having one electron here, one hydrogen atom is having one electron here, one hydrogen atom is having one electron here. They share mutually and form a single bond with the hydrogen. Here is also one hydrogen, here is also form a single bond with this hydrogen. This carbon also form a single bond with this hydrogen. This carbon is also form a single bond with this hydrogen. Two pair of electrons are in between two carbon atoms. This one pair and this one pair, they will mutually share these two electrons between two pair of electrons between two carbon atoms, and to form a double bond or double covalent bond between two carbon atoms in ethene molecule. Two pair of electrons are formed. So this is a double covalent bond or double bond is formed between two carbon atoms in ethene molecule. Okay, let us consider another example, that is ethyne. In ethane molecule, carbon atom forms triple bonds. So three electrons are in between two carbon atoms should be there for triple bond formation. One electrons are there on the other side, and which will bond a single bond with the carbon and hydrogen. Here is also a single bond with the carbon and hydrogen. The remaining 6 electrons are there in between two carbon atoms. This 3 is the part of this carbon and this 3 is the part of this carbon. They mutually share their electrons to form a triple covalent bond or the triple bond. This indicates that single covalent bond, double covalent bond and triple covalent bond can easily form by between carbon atoms. So this also indicates the versatile nature of carbon to form 3 million plus compounds. Okay.